And when are we? So we're getting close. So determine whether it's a function. This is kind of a funny, strange thing. It's not hard, but it's weird. Does anybody already happen to know there's a certain rule for being a function? I wouldn't suppose you'd know. It's kind of a weird thing. Every x has only one y. Seems kind of strange. So every x value connects with only one y value. Every x connects with only one y. That's the rule for being a function. So, yeah, and we'll talk more about why that would be later, but that's the official definition in the math science world for something being a function. So they're asking me, is this a function? That's kind of weird to look at. Like, I don't know, this is a bunch of numbers. What do you mean, is that a function? Well, they're numbers with commas in between. Remember what we always do when they have commas? That means this is an x, and that's a y. This is another x, that's a y. This is an x, that's a y. This is an x, that's a y. I think it's easier if I lay it out vertically. So 2, 7, that's x, y. 8, 4, that's x, y. Like a table, it's just easier to look at, I think. -9, -9, that's x, y. 4, 4, that's x, y. So, let me ask you the question. Now looking at it that way, does every x connect to only one y? The answer is actually yes. You might be worried about the 4 thing here, but that's okay. Let me tell you what would not be okay. What would not be okay is if like I had another 2 and it went to 8. That would be a no-no, because then you would have 2 going to 7, the x value of 2 going to 7 here, and then 8 there. That would be a no-no, and we'd say not a function. Because every x value, like 2, can only go to one y value. Can't go to 2 different y values. That's the big no-no. Anyway, ours is good. We don't have any of that. You might say, well, yeah, but what about 8 going to 4 and 4 going to 4? That's okay. You can have 2 x's go to the same y. That's actually okay. But you can't have one x going to 2 different y's. That's the big no-no. Every x must go to only one y. So yes, that one's a function. Next, they're going to ask us, what's the domain? Does anybody know domain already? Again, this is kind of weird stuff, not hard, but weird. What's domain? It's simply the left side, the x's. The domain is the x values. It's just a word we use in math science for the things plugged into the function, the x values, the starting values. So which of those is the right domain? It's this one here, huh? And guess what the range is? Yep, the other side. So what's that? It's that first one, huh? You don't repeat the 4, notice. Right? It's just the different numbers on the y side, 7, 4, and -9, in any order. So it's kind of different. Not hard, but different. We good with that? So there's number 1. Every x goes to only one y.
In the domain, you don't repeat the numbers also. You just...
Right. You just list them. So the domain is just all the x's. The range is all the y's.
Okay, so we start with the first, we get in the function, and then the same numbers out on the bottom, so we find out what are those domain, what those belong to the range.
Yep. Yeah, domain is the x's, range is the y's. That's right. It's strange. So take those and put them in a table. I think it would be much easier if you just put them in a table. They're kind of hard to look at going up and down like that. So x and y, so it's just 5, 3, and 5, 4, and 5, 6, and 5, 7. Okay, so remember the function, right? For the function rule, function has a certain requirement. Every x must go to or connect with only one y value. Only one y value. So is that one a function? No, it's terribly not a function. The x value of 5 is going to several different y values, right? So that's not a function. Oh, are they even asking me? Maybe they didn't even ask me. Does it? Oh, yeah, down here. Yeah, so it's no, it's not a function. Now they want me to start with the domain. What's the domain on that one?
5.
Yeah, just 5, huh? Because domain remembers the x's. There's only one x there. It's 5. And what's the range?
3, 4, 6, 7.
Yeah. 3, 4, 6, and 7. Any order, doesn't matter what order. They say commas, just separate them with commas. That is the range. The domain is the x's, the range is the y's. And the function rule is every x must go to only one y value. And so that one's not a function. Easy enough? Kind of strange, but not too hard, right? Questions? All right. Always use in math classes for a function is a toaster. A toaster is a function. You probably don't think of your toaster as a function. But it is, meaning what? You put stuff in, bread, frozen waffles. You put it into the toaster, it toasts them, and out comes toast or toasted waffles. That's all a function is. It takes stuff in, does something to it, spits out something that's different. That's all a function is. So we're looking at a function in more theoretical ways here. So here they're saying, all right, arrow diagrams. See, I could write the toaster function. If I want to give you something physical so you get the idea. I could write bread goes to toast and frozen waffles goes to toasted waffles. And that would be my toaster function. Get the idea? Over here is the x's, the stuff you put in to the function, to the toaster. And over here are the y's, the range, right? Domain and range, x and y. That's all we're talking about. That's all we mean. That's all function is. Put stuff in, does something to it, give you stuff out. So now they're trying to give us a diagram with planets and the number of solar Congress representatives. I don't understand that at all. Whatever. Just connects to those numbers. Whatever. Anybody know what that means? What does that mean? Solar Congress representatives. All right. You don't know either. All right. Whatever it is, we'll connect with those numbers. So Venus has 18 of them, whatever they are. And Neptune also has 18. And Mars has 26. And so does Jupiter. And on you go. All right. So first question. What's the domain? Domain. What's the domain? Left side. It's always the left side, huh? It's the x's, the left side. So yeah, it's the planets, yeah. Venus, Mars, Jupiter, Saturn, Neptune, Pluto. I thought Pluto wasn't a planet or something. Did we hear that few? So, well, anyway.
It's a big controversy, yes.
Is it? Okay. So it's more than I know.
Exactly.
The big
All right.
mystery, put it like that.
What's the range?
18, 20.
The
This side.
representative was-
Range is that side, those numbers. It's just that first one, isn't it? Yeah. All right. Is it a function? So does every x go to only one y? Let me write that again for you. This one's a yes, I think, right? Every x goes to only one y value. Yeah, it's okay that they, like both Venus and what is that, Neptune, go to the same. That's okay. It's just what would not be okay again would be like if Venus went to 18 and then Venus also went to 20. Right? Like, what is it? Does Venus have 18 or does Venus have 20? That would not be a function because that's the same x going to two y's. You see how that wreck it? See how that just make it crazy? Or with your toaster, you put in bread, it goes to toast and frozen waffles. You put in bread, who knows what's coming out of that toaster? That'd be crazy. That's not a function. Right? So, yeah, every x has to go to only one y. So this one's, this one is a function, huh? This one is, yes, a function because every x does go to only one y. We don't have any x going to two y's. All right, we good there? Questions, comments? Is that one a function?
No.
Yes.
Yes. Every x goes to only... You never have a single x, like if 2 also went to some other number like 5 or something. Then that would be a problem. Because hey, look, 2's going to 1 and it's going to 5. Which one is it? That would be the problem. But we don't have that. It's okay if they all go to the very same number. That's still a function. What's not a function, this would be yes, a function, every x goes to only one y. Literally, all the x's go to one y, don't they? On this one. That's okay. The thing that's not, so just keep in mind what's not okay. What's not okay is a single x going to two y's. All right, what's the domain?
2, 4, 2
These.
minus 4.
Yeah, left side, domain 2 minus 4, 6, 107. What's the range?
1.
Yeah, the range is just, that right side is just 1. Done. Good? Easy enough? Vertical line test before? So basically we're still doing the function thing. And here's the vertical line test. So the vertical line test. You can put this on your 3x5 card that you get at every exam for the exam week after next. Vertical line test. For a function, I should say, it's another function test, but it's a graphical function test. So for a function, to be a function, how about that? I should say to be a function, every vertical line must hit the graph only one time. Every vertical line must hit the graph only one time to be a function. If you ever have a vertical line hit the graph twice or more, it's not a function. So there's the graph. It's that blue diagonal line. So if I start taking vertical lines, it means straight up and down lines, huh? If I go straight down, boom, it hits only once, huh? Straight down hits only once. Straight, every vertical line only hits once, huh? So that's a function. Why do they have all those options? Why isn't it just yes and no? What are those? It's not a graph. No, it is. So it's not, see, here it says not a graph of a function, not a graph of a function. So those are out. Forget it. BEC says is a graph. Yeah, but what? Because a vertical line can be drawn that will intersect more than once? No. It's D. Because no vertical line intersects more than once. The answer is D. Because no vertical line hits more than one point. That's the same thing as saying every x must have only one y. Do you know what I mean by that? Think about this. What if you had a graph like this? That would not be a function. Because here's a vertical line that hits 2 points. So that's not a function. Do you see that a vertical line hitting 2 points is the same thing as saying one x has two y's? What do I mean? Well, like, what might be the coordinate? Let me just make up some numbers here to show you. What might be the numbers there? Maybe that's over 5, up 3. I don't know. I'm just guessing. And what would this point be? Over the same amount, huh? Because it's a straight vertical line, so it's over the same amount. I don't know what, maybe down 2 or whatever. See how that's the same x going with two different y's? See how the vertical line test, a vertical line hitting 2 points, means one x has two heights, right? Over 5, or whatever that's over, you know? Say that's over 5 on the x-axis, right? If a vertical line hits 2 points, that means over that amount, wherever that vertical line is, at that x, there's two y's. And that's the big no-no. See how the vertical line test is a graphical way of doing the same thing, saying you can't have one x hitting two y's. You can't have a vertical line hitting 2 points. So that's the that's the graphical way we test, the vertical line test. So it makes sense? We're getting these function tests. Let's try another. Okay, does that one... So try shooting some vertical lines. How many points? Just one. Just one. Just one. Every vertical line is going to hit only 1 point. So that's a function. You just don't want 2 points, like you don't want two y's. That's a function. Whatever one says that is a function because... Wait, I think it's C this time, isn't it? Wait, no. They really mixed them all up here. Is it C? No, not a graph of a function. That's not what. Not a graph. No, it's A, right? Is a graph because no vertical line hits more than once. It's A. So you just got to read those words carefully. They're being tricky. Yes or no would be better. All right. So we good there? Does that make sense? If a vertical line hits 2 points, it's not a function. If an x has 2 y's, not a function. Otherwise, it's good. Is that a function?
No.
No way. There's a vertical line hitting a bunch of times, huh?
4 times.
On and on it goes. No way. So is a graph of a no, not A, not B. Is not a graph. Which one of those is right? Because no vertical line? No. Because there is a vertical line that will hit more than once. D. There is a vertical line that hits more than once. Not a function. Because a vertical line hits more than once. An x has more than one y. We good?
That last one was a function?
This one was a function because every vertical line only hit once on the graph. But number 8 is not a function because vertical line hits more than once on the graph. That x has more than one y. H of -1. Okay, so what is it? Have you done this kind of thing before? We're going to plug into the function. So how it works, how you plug into a function, is the x to the right is like the holes in the toaster. It's where you insert whatever's in the parentheses. In other words, here's how I like to describe it. It's like they're saying this, and it slides down right there. This x is telling you to go right there. Like whatever you put in the toaster, so I'm going to plug something in the toaster. They're telling me to put -1 in the toaster. I'm going to put -1 into the toaster, and it's going to slide. It's going to go right there, and the -1 will show up. That's like the guts of the toaster. That's like inside the machine. So that's what function notation means. The x is just holding a space. I really think they should have just made it parentheses. It's just holding a spot. That's all it's doing. So whatever you stick in the toaster, whatever you put in the parentheses, just slides down and shows up where x is. Now, remember, it takes the place of x. X won't be there anymore. It's going to replace it, like a substitute teacher, right? Takes the place of the regular teacher. You don't have the regular teacher and the sub both there, right? The sub only shows up when the regular teacher's not there. It substitutes. It takes the place. So it'll be like this. Makes sense? It takes the place of the x. And you always put parentheses around stuff you plug into functions. Is that good? All making sense? And then you just work it out. So what do you do first to work that out? You can use calculators. What's the first step? Yeah, you do the power thing first, huh? -1 squared. What's that? -1 times -1? +1. And then what do you do next? Multiply. 9 times 1. Answer's 10. So that means you put -1 into the toaster. Out comes 10. This toaster, this h of x function. So that's all it is. You just plug it. Whatever's in the parentheses replaces the x with parentheses around it, and you just work it out. That's input, output. That's the x, the y. We put in -1 to the toaster, out came a 10. Let's try. So they're giving you the function g of x equals that, and they want you to put into the toaster, put into the function 0. So can you do that? So all you have to work with is the right side, huh? This stuff. And everywhere you've got x, just replace it with parentheses 0. Parentheses 0. Both those x's on the right side will be replaced with parentheses 0, parentheses 0. And then just work out the number on the right side. So it's going to be 3, 0 squared minus 2, 0 plus 5. Okay, what's 0 squared?
0.
And what's 3 times 0?
0.
And what's 2 times 0?
0.
What's 0 plus 5?
5.
It's just 5. Making sense? All right, let's do number 13. Try number 13. Here's the toaster, here's the function. They want you to first plug in 6. Now, the weird thing about this one, let me write it up here.
I don't.
So we're going to plug in 6 right here in part A. They want us to plug 6 in. So I take the right side, and everywhere I have X, I don't have X. Everywhere I have X, I replace it with 6. Okay, I did. Because there is no X. There is no X on the right side. So they're telling me, take that right side, and everywhere you've got X, put 6 in its place. Okay, I did. Because there is no X. So what's the right side? 1, like it started out. What's the next one? 1. What's the next one? 1. You see, there's no X over there. So it doesn't matter what you plug in. It's not going to the right side because there's no X on the right side. The right side is going to be 1, period. Does that make sense? Kind of weird. I know this is a weird section. Not hard, but weird. Did you see that? It's because the right side doesn't have an X, does it? Now, it would be different. Maybe it'd help if I showed it different. Like, what if instead of that, they had said f of x equals 1x? That would be different than just 1. In that case, if I plugged in 6 or whatever, I would have something somewhere to put the 6, right? Remember, the x is the holes in the toaster. The x gets replaced with parentheses. In that case, 1 times 6 would be 6. That'd be very different. They didn't give me any x's on the right side. So doesn't matter what you plug in. That toaster has no holes. You can't get anything in that toaster. It's just going to give you out 1 every time, no matter what you plug in. They're just testing that you know that. Is that making sense? So you always put the number where the x is. If there's no x, then there's nowhere to put it. It's just the 1 on the right side. All right. Language. So they're saying g of -1 equals 5. Use the graph of the function to write the corresponding ordered pair if g of -1 equals 5. What are they saying? Well, remember what we talked about earlier for functions. We said that whatever you plug in is x, and what comes out is y. Yeah. So when they tell me g, oh, by the way, this doesn't mean multiply. I should say that. I forget. This does not mean multiply. This does not mean g times -1, which is kind of weird, huh? We're so used to parentheses always meaning multiply. They do not mean multiply when they're next to a function letter. They mean plug in. They're the holes in the toaster. This means -1 plugged into the g toaster, not g times -1. How do you know? Because it's a function. You just have to know the context that you're in. They're telling me this is a function. So it's g, how you say it is g of -1. I'm not going to give you an oral math exam, but it might help you just to hear those words and think about it right. It's g of -1, not g times -1. Meaning it's -1 plugged into the g toaster, not multiplied by. So anyway, so what? So you plug in the -1, x, whatever you plug in is always called x, and whatever comes out is always y. So that means x, so they're telling me, they put -1 into the toaster, out came 5. X is the -1, y is the 5. And what do they want from me? Well, they want an ordered pair, which always means, remember whenever they want ordered pair, they want parentheses? -1, -5. It's like kind of dumb. There's like nothing to do. There's nothing to add, subtract, multiply. We don't even need to look at the graph, it turns out, on that one. We will on the next one. It can like fool you because it's like too easy. You just want me to put those two numbers with a comma? They do. They're mainly checking that you speak the language. There's not hard manipulating things to do here. It's do you even speak their language? Do you know what they're saying? Function language. This is x, this is y. So when they say ordered pair, you go, oh, okay, x comma y. Ordered pair always means parenthesis, comma, xy. You know, it is a point in the graph. I mean, technically the graph does support that truth. We don't need to use the graph. Do you see the point right here? That is the point they're speaking of, negative 1, 5, right? Back 1, up 5. That's that dot on the graph. We don't have to do anything with it. We will on the next one. So I want you to see that. Okay, so they're saying f of 0 equals what?
-6.
F of 0 equals what? So, how do you, again, there's nothing to add, subtract, multiply, or divide. It's super simple if you speak their language. It's all about speaking their language. So how do we speak function graph language? You just remember that whatever is in the parentheses is x, whatever it equals is y. That's the key to speak in their language. So that means you're going to go over here to the graph. They're telling me this is the graph of the function f. Use the graph of f. They mean that. Use that graph and find the dot. Find the spot on that blue graph where x is 0. Which dot has an x value of 0?
-6.
This one right here. That's over 0, down. That's x 0, y -6. That particular dot, huh? Whereas, like, there's other dots. Like that one looks like, I'm just playing around here. That looks like 3.5 up 0. And this one right here looks like over 3 down 2, etc., etc. I don't really care about those other points. But I just want you to see, I'm just grabbing a point, right? Remember, x is over, y is up, down on a graph, right? X is sideways, y is up, down. So this is the point over 0, down 6, isn't it? From the origin, from right here, you'd go over 0, down 6, and you'd find that dot. So they're saying, go to the graph, find the point with an x value of 0. I did. And give us the y value, please. Oh, okay. You just want the y value? -6. That's the answer. We're done. Does that make sense? Once you know what they're saying, it's an easy question, but it's all about speaking their language. Want to try number 16? So don't say the answer out loud. Give everybody a chance. Look at that graph and see if you can. You don't even need to read all those words. All you need is this. They're saying g of x is 8. Find the x. So what is this 8 here? Is this an x or a y? Why? Because y is always on the outside, x is always in the parentheses. Always. It's by common agreement in the math science world. They said x's will always be what's in the parentheses, y's will always be out here. That's just common agreement. So they're telling you y is 8. Want to make that bigger? So where do you see on that graph, like say you're riding the roller coaster here. I'm riding the...
Oh, the other here.
I'm riding the roller coaster. Go up here and down there. I'm riding the roller coaster. Where will I be at a y value of 9? Y value. This is the y-axis, huh? Here's 9 up here.
9 is G.
Boom, boom, boom. Those 3 dots. Now I'm only going to give the right one because they said positive only. But at first, what's that?
You're looking for 8, not 9.
Oh, 8. Yeah, sorry. No, you're right.
But it was
8.
G, no 9.
So it's supposed to be there,
9
there, and there. Yeah, g of x is 8.
You're making up.
You making up a different problem, Manuel? You want a 9? I think it's 8. All right, so it's those.
Like a G, but...
Those three are at 8. Yeah, so those 3 are at a height of 8. Now, did they say only the positive? I didn't notice that. I guess they said, so really this would be the point. Let me just list them all at first and then this is back 8, isn't it? No, back 7, I think. Isn't this back 7? Yeah, it looks like it's back 7 up 8. And this one's what, -2? Back 2 up 8. And this one's 4, yeah. Over 4 up 8. They all have a y value of 8, don't they? And they have different x values. Now, so they said, give me the x values, please, that go with a y value of 8, but they asked for only. So normally I would say, okay, -7, -2, and 4. -7, -2, and 4. But they said only the positive one, please. So just the 4 is the answer.
So is that a function?
That is a function. That graph is a function because it passes the vertical line test, right?
Yes.
Yeah. that make sense what we're doing then? We're just finding the points that have, just remember, x is in the parentheses, y is out here. Find the points with a y value of 8. And then they wanted only the positive x. So we had, we had x was -7, -2, 4, but they didn't want those two. So it's just x is 4. It's just this one is the only one they want. So they want us to graph f of x is 4x plus 5. F of x is 4x plus 5. So do you remember anything about graphing? They have it in m63-8. It'll be easy, quick to review. So f of x, that's the same as y. Just make that whole thing y. So really it's y equals 4x plus 5. So remember how this works? We're going to get two dots. This is going to be a straight line. And how we get the straight line is we find two dots and just connect the two dots. And we'll have the line. Does anybody remember how you get your first dot? Yeah, this number right there. You start up 5 in the middle. Yeah, that number that's off to the right is always your first dot, right on the middle line, positive up, negative down. So that'd be right up here, boom, at 5. That's my first dot. I'm halfway there. Remember that? That's called the y-intercept. That's what it's called, if you remember. Now, how do I get my second dot?
With a slope?
Yeah, what is the slope? Where is the slope?
4/1.
Yeah, right here, this is slope, and it's rise over run. Remember, slope is rise over run? I just made it look like a fraction. 4 is the same as 4 over 1, right? 4 divided by 1 is still just 4. And now that's rise over run. And so that's how the steepness, the slope works. It goes up 4 over 1, up 4 over 1, up 4 over 1. It just keeps going at that level of steepness. So you start from the 5, and you go 1, 2, 3, 4, up 4, over 1. Up 4, over 1. And then put another dot right there. And then the computer will automatically connect the dots for you. In fact, maybe I'll show that in a second. Is that good how that worked? There's the line.
And is it pointed or hard? What's it?
So just those two dots, it makes the line automatically. Oh, solid. Yeah, it's not dotted. Solid. So we started at up 5, and then from there went up 4 over 1. You want to start number 18? Go ahead and do 18, and I'll get up. Meanwhile, I'll get up on Math Excel with me. So they're giving me y equals -9. There's no number off to the right, so you just put +0, because that doesn't change anything, right? Adding 0 doesn't change anything. So that means your first dot is right at 0. And then you got to find your second dot, which is going to be. Okay, so y equals -9x plus 0. So we start at 0, and what's the slope? Yeah, so rise over. How do you rise -9? Down 9, huh? So I'll go all the way down 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. So down 9 over 1, way down. There it is. There's the second dot, and it'll automatically make the line once you click the two dots. There it is. Yeah.
When you go, so I know you go down because it's negative, but then why wouldn't you go the other way?
Yeah,
Like,
because
would you
this
ever
is
have
positive
that?
one.
But would you ever have that to where you go down and then?
Really good question. Yeah. So let's talk about it. Really good question. So y equals -9x plus 0. So let's think about what we know about negative signs and fractions, and then see the same truth beautifully reflected in graphs. So we put this over 1, and because that's -9 divided by +1 is still -9, huh? Haven't changed anything. I made that a positive. That's why I went right, because it's +1, down 9, right 1. But the good question being asked is, well, couldn't you take that minus and put it on the bottom and make this plus? Isn't that still -9? Yes, it is, right? Because positive over negative or negative over positive, either way, it's -9. That's another valid way to write -9. So would that work on a graph? Of course, math always works. Let's see it. What would you do from here? From the origin, you'd go what? Up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 9. And what? What's negative mean now?
One to the left.
Back 1. Right there. Now, I didn't graph so well. It should be, it's just a sign of my
And
poor
then
graphing
the
skills.
same line intersect
In the end, it's the very same line, isn't it? The line goes forever both ways. It's the very same. You'll get the very same line in the end, although you're using a different point to get it. It'll work either way. Math always works. Isn't that beautiful? As long as you follow the truth. Yeah, so either way, I think it's easier just to put the minuses on the top, so I just always do that. I always, when the fractions are negative, I just always put the negatives on the top, and that just tells me I'm going down, and then the bottom, I just always go to the right. I just found that's easier for students just to always go to the right, but you could do it the other way.
Would
The
you
same
ever
truth.
have like a negative on the top and on the bottom?
Well, you would just make that positive,
Right.
but it would still be true.
Oh,
So like if you said, I got -2 over -1, plus 0 or whatever. Well, then you'd start out at 0 and you'd go, I mean, you can always follow it. You would go, what is this? This means down 2 and left 1, doesn't it? So from here you'd go down 1, 2, and left 1, right? So there would be your line, right? But isn't it the same as if those are both positive? Of course it is. So that's the same now as what? Right 2, wait, did I do that right? No, sorry, it's up 2, up 2 over 1. So yeah, these two dots are going to make the same line as well. It always works.
They're the same.
Math is a system of pure logic. So as long as you follow the logic, it'll always be right. All right, so style doesn't matter. So let me show you real quick about on the thing. It's super easy. So there it is. So here's number 17 that we just did. Different numbers. 3x plus 5. So where do I put the, for here, I'm going to blow it up big here. Where do I put the first dot? 5. So you come over here and you click on the line maker tool. See this tool? So I'm going to see the line with the two dots there. Is click on that line maker tool like that. There's that. So, okay, can you graph that one? Y equals minus x minus 1.
You start
So find your
minus one
starting
bottom,
dot and then find your slope.
and go down -1 also. And
So we're going to start
to the right.
right there at -1. That good? It's always on the middle line, huh? Your first dot's always on the y-axis. It's a y-intercept. Down 1. And then what's my slope?
-1.
Yeah, -1 over 1. Right? If there's no fraction there, we need there to be a fraction there. What fraction could I put there that won't change anything? 1 over 1. 1 times x is still just x. See how that doesn't change anything? Right? 1 divided by 1 is just 1. Or -1 divided by 1 is -1. Times x is still just -x, isn't it? But now I have something to work with. Rise and run. So go down 1, over 1. There's my second dot. That makes sense? Down 1, over 1. Connect the dots, or the system will do that for you automatically. There's your line. All right.